that uses eBPF. Okay. Okay, then I guess we are all in for a little bit of learning today. So, what is the threat? Why do we need to secure our CI/CD pipelines, right? Why are we having this talk today? CI/CD pipelines have become high value targets for attackers because most times, um, we already have tools that are checking for malicious malwares and they're scanning code scanning, code profiler tools, right? But then oftentimes they miss to identify malwares that run in runtime behaviors. So now by using eBPF technology to scan our CI/CD pipelines, we get, because that's the first stage. That's the first stage where your application gets to run on a similar environment that it's going to run when you push it to your production or development environment. The CI pipeline is the first stage for it to run on a runtime environment, right? So that's also an ideal place for you to be able to check whether everything is appropriate and if you have any vulnerability, right? And how do we go about this, and um what's the current threat that is we're facing? According to Sonotype, they just did a survey, I mean, some findings this year. And in just this first quarter, they found 17,000 new open source malware packages were identified. And that brings the total number of identified malware packages targeting developers to a staggering number of 828. And this is a huge jump coming from 2023, where we had around 200, where they identified about 200,000 packages. That's to show that like data exfiltration threats are rising rapidly, and meaning organizations also need to tighten the way they're going to tighten their security policies, right? And now
Rashida,
let's look at
Rashida, I have a quick question. Can you go back to the previous
okay,
slides? Is it because of
sure.
these, the raise of, you said that there's these many packages are identified to have malware, right? So
Yes.
is this due to the raise of AI, or why is that there is a sudden spike of it? Or are you going to be talking about
Um,
that?
Okay, I didn't cover that, but I think mostly I really believe it has a lot to do with the use of AI, because everyone is able to build something, and then there's a lot of people are building stuff without enough knowledge on how to secure it. So it's very easy for you to steal users' data, right?
Mhm.
But then I also added the link um
Mhm.
to the press release on this
Mhm.
new discoveries. So you could, after this talk, I know we could share the slides, and you could also check out this report and find out more information on why there is a jump, right?
Okay,
But then
thank you.
okay. But yeah, the key findings from this report, right? Data exfiltration malware dominates. About 56% of the malware discovered were related to data exfiltration. They are designed to steal sensitive information from the infected systems. And then we also still have, we can still see that resource hijacking is prevalent, with about 77% of this malware are around crypto mining and for resource hijacking. And also we see that finance services and government institutions are majorly the targets of all these attacks, with 66% as services, which makes sense because everyone wants to steal a financial data. It's a very valuable data to steal. And also about 14% are targeted at government organizations, and 7% at utilities and the likes, right? Now, how are these attackers? That's to show that attackers are actively targeting organization. And how do they really go about this? What are their common attack vectors? And they're usually doing this via vulnerable packages, or they compromise your pipeline tools, and or compromise your artifact registry. Now, how do they? Let's go into this, right? They can go ahead by using the vulnerable packages. They can go ahead and publish. Recently, there is a finding also from Sonatype, where they found an npm package called the execution time sync, which was traced back to a North Korean hacker group, where they used a typo scouting attack to publish a package that resembled the legitimate package called execution sync. That package is actually a code profiler package that just checks your code. But then instead now using that a name that is very similar, and they called it as execution time sync, which is very similar, and developers could really just mistake this for and assume it is the other package. But this particular package now has capabilities of stealing your users' passwords and credentials, and it also has the capabilities to download a Python script remotely and use it to compromise. And that Python script has information on how to. I mean, that Python script allows them to remotely control and compromise your instance. Now, this is a typical example. This is a typical example of they use how they can compromise your how you could just developers could mistakenly use these packages, and then none of this regular tools that we use to scan our code bases identify that, because most times they are not activated until they're in a runtime environment, because it also need access to once you've run that particular application. um once you're on the application, and then it downloads the Python script, and now you will never have an idea that you're you just find out you're having issues and your resource has been hijacked. So, and another way of them using compromised pipeline tools is also using the typo scouting attacks, where you use a pipeline tool that you think, oh, it's just benign, not knowing that um they have also it has been compromised to send out sensitive information. And now we have um so looking at this common attack vectors, and this is how the attackers are thinking, and these are the strategies they are using to attack us. uh that is where we started. That is how control came about, and then control also used eBPF technology. So I just want to take us through what eBPF is, and how it come about, and then how control uses eBPF to build their tool, and how it basically works fundamentally. Right now, what is eBPF? Before I go into that, I would need to just go back a bit, right? The operator eBPF works. The operating system is, so basically the OS where you are running your application is the ideal place for us to implement observability, security, or a network functionality, because the kernel has um, privileges to oversee and control the entire system. Right, it can see every program that is running, all the events that is being triggered. But at the same time, the operating system kernel is hard to evolve due to the high requirements towards stability and security. You can't just go ahead and mess with your operating system and say, oh, you want to extend this functionality. You want to be able to observe what's going on in your OS. You really can't do that, because um, the rate of innovation when it comes to the OS is really tight. You can hardly just make changes anyway, anyhow you like, right? Now, eBPF comes to change this, because when developers want to extend the functionality of their operating system, so eBPF comes in to create a sandbox environment where you can run programs within the operating system and extend the capabilities of your operating system, but without fundamentally messing around with your kernel. And so now developers can run eBPF programs and add additional capabilities to their operating system at runtime. And how that works is we have particular hooks in your kernel environments that you can attach those programs to. Like now, if you see this diagram, you could attach your eBPF program to like your the networking interface, right? And ePPF programs are usually event driven. So whenever a process or an event triggers a particular hook point, um, or a predefined hook, such as like the networking hooks, or let's say your storage, your syscall, if you attach a ePPF program here, now whatever networking process that is happening in your operating system is going to be monitored by this program, and then it can also send it can track all the events and log them out to the user space. So the user space is where application developers can now interact and make do with that information. Once you've gotten the information of all what's going on, um, it creates maps and send those maps to the user space. And in the user space, you can now decide, okay, you can now observe what is actually happening right from the kernel level. And then you could also implement some policies or some blockers to say, okay, you don't want, now this is right from it doesn't even have to get to the TCP level, but right from the kernel level, I don't want my applications to be anything running on this machine should be able to access any of this website. Or I don't want, you could run program that you want to see, you could run a PPF program that you want to see all the processes that are opening any file storage or writing, reading or writing to any um, file. And you could observe that. That way you could see whether um, you see whether any program, what your programs are doing, how they are performing, and now whatever you will do with that information is now left to the developers. And now in
Uh,
this case, this is how you have a question.
yes, I do. So,
Okay.
uh, is it possible that you can have this? I have no clue. I'm just asking you as a a person who does not know
Hmm.
anything about the eBPF. So,
Yeah.
how can you put this program into cloud machines? Is it possible?
Yes, it
And is
is.
it
And
is it also free? Is it
yes,
free or
EPBF
there?
is so EPBF itself is basically like a as a package that you can it's a C level program package that you could manipulate whatever way you want to just use it to create your own programs. And
Mhm,
control is a tool that uses ePBF technology, right? Control
mhm,
itself is also free. ePBF is an open source um program also, so they are
mhm,
all free to
mhm.
use.
Okay, thank you.
All right. So now that I've spoken a little bit about like the technology that control uses, right? How does control uses eBPF? Like I said, you attach the eBPF agents to different hook points in your kernel. So instead of you now going ahead, like Deepa just asked if she could do this by herself. Now, instead of you to go about the complexity learning C or using Python to write BPF programs and doing all those I call them boring stuff yourself. They have already done that. And now all you have to do is just apply a particular step to your CI/CD pipelines. But then that's something that I'll get into in a bit. So basically what they do is okay, let's go here before I come back here. Now the playbook on how here's a breakdown of the playbook on how control uses it. Like I said, your ePPF agents or ePPF programs is being attached to different hook points, and control focuses on the traffic control layer. So based on the activity on the CI, it uses eBPF to attach a kernel call and send those calls to the user space that flag any anomaly behavior. That is what, so control also have like a monitoring just to observe what is going on, all the everything that is happening, and it can also flag any behavior that it doesn't seem appropriate. And then you also have prevention capabilities where you apply policies, and these are okay, you don't want it to access any of this external URLs or something. You apply those policies and they go down from the kernel level, they are being applied using this particular tool. So here, like I said, they focus mostly on the um, they focus mostly on the traffic control layer. So you'll see it also probes the TCP events. So they are in our kernel now. There are key probes, which is like kernel probes, and it also hooks this eBPF agent to the TCP v4 connect key probe, the TCP close connect key probe, and also you also watches our UDP events. It attaches our programs to the IPv4 datagram connect key probe. So any TCP or UDP based connection that is happening on the networking layer are being watched closely, and all the egress traffic, whatever connection that is going out of that particular machine, is also being watched. Those events are being tracked, and you get a report on those events. And then also you have the capability to set your policies of what are available to what you want to allow to happen, and things that you want to block. And so they have a user space that be made ready to go, right? So in this case now, let's say you're just running the CI pipeline, and when you run this, and this is your task right now on the machine, you run npm ci. This is going to install your npm modules, right? And this process is happening there's a lot of syscalls happening, and while the eppf agent is there watching all the syscalls that are happening, watching all that is happening on the traffic control layer, and ensure that, okay, this looks normal, this looks like normal behavior, and it generates a report after your pipeline have run. And I'm just going to quickly show us how that happens in real time. And for that, I'll quickly show us the workflow file itself. So here is a quick
Are you
workflow.
sharing? Are you
Oh,
sharing
sorry,
a
let
different
me,
screen?
yes. Okay, I've switched my tab. Can you see
Okay.
that now?
Yes, yes.
Ah, okay. So here is a sample workflow file, and basically just your normal stuff. This is running on GitHub runners currently. I'll also be demoing how you can do this on your self-hosted runners, and this is it's running on your Ubuntu latest GitHub runner. And basically, all we want the CI to do is just echo hello world. So now, if you want to implement this in your own infrastructure, this is the step you'll need, where you run the step is just run control, and this is the control wget release. This is where you install the control package on your runner, and you activate the package, and then you start. This is in the trace, just like you just want to trace what's happening, and then you can specify the allowed host. So these are URLs. This is how we specify some policies on this level. You could say, oh, you only want it to be able to access the now, control is also a tool made by Conductor, right? So you want it to access the conductor.io website. You want it to be able to access docker.io and docker.com. And that's it. These are the only URLs that you want it to be able to access. This pipeline to be able to access. Any other thing else is not allowed. And now we're just going to test how this works. We're just going to simulate a simple anomaly behavior, where I have this secret called my secret, and I have this curl request that is going to, you could see the request is also requesting for my secret. And now what this curl request normally would have done is to send the secret, whatever value it is that is my secret here, will be sent to this webbook website, which is definitely not something that I normally would want to do, because a secret is a value that I would want to keep in that build step. And that's it. I definitely do not want to export them out. So these are one of the ways that all this malware packages steal your secret on credentials in runtime environment. And if the curl request doesn't work, depending on the machine, it also has a backup to run it, and using the wget request. So these are actions that we're going to watch and see if the control tool can prevent from happening, because this webbook website URL is definitely not part of our allowed hosts URLs. And now let's run something that we actually want to allow. Remember earlier we allowed this download.docker.io as an allowed host. So we're just going to try and download an artifact from this particular URL, and we're going to see if that happens, how that if that works out. And we're going to generate a report. So all reports are usually sent to the temp folder in that particular runner. So we're just going to print out that report and stop the control tool. So let's run this job. So you can see it has printed hello world. It's installing the control tool to our runner. Mhm. So while this is running, okay, I don't want to take us. Is there any questions so far? Is something you want me to clarify?
Any questions, folks? You can put it as a Q&A if you're shy, or you can also unmute yourself and ask. Ask away while this thing is running. This is my first time seeing this, so don't.
Really?
Yeah, I've not heard of this particular filter.
Okay.
I don't work in the DevOps side, so.
Yeah.
What platform support what platforms support
BPF.
eBPF?
So mostly all Linux environments. Sometimes depending on the machine types, there is a little bit of configuration tweaks, but mostly all Linux environments support eBPF. Okay, so our run steps is complete. It has installed control, and now
Oh,
let's take a look at
Rashida, there is also another question. How about Mac OS? Does
Mac
it
OS.
support?
Yes, it does. It does.
Okay.
So now let's look at this. This is, if you're okay, I want to pull this up side by side. Okay. But for now, remember our stop prevent action step where we had a URL that is going to send out our secret. Remember when I walk us through that step? I'm just going to share this tab for now, and you could see it here. This is the step that was sending, that attached our secrets, which was supposed to be an environmental secret for this pipeline to run. It embedded it in the URL and is trying to send it to this webbook website. Now, when you come here, you would see that it failed. It was on. It's even completely unable to connect to the webbook site using port 43. All attempts to reach that URL was completely barred. It didn't even get to leave the kernel. That is how eBPF blocks things, and that is how the control tool blocks things. And now let's look at the allowed action, where we wanted to download an artifact file from the download.conductor.io web URL, and this file was downloaded successfully. It was saved into my artifact.txt, and that's the file name, and this is the content of the file, right? And so this is an action that we allowed to pass based off the policy that we gave it. Remember in this step, back here. Yeah, in this step, this is like our policy. If you're running this on a single CI pipeline, this is where you specify the policy that you want, and this is the allowed hosts. These are the allowed URLs that we want, and okay, sorry, I'm showing you the wrong tab again. Sorry. So these are the allowed hosts that we have, and conductor that download or conductor.io was allowed, docker.io was allowed, and the likes. And we can see that all attempts to reach this webhook site was all the connection timed out. It failed to connect to the webhook.site using port 443. It tried, it couldn't. All several attempts to reach it basically just said network is unreachable, completely logged, stopped. And when we look at the run allowed action, where we try to download an artifact file from the download.conductor.io website, we're able to download it. We were able to, the connection was connected, was allowed. The connection, we got the 200 response, we're able to download it. It was able to reach the docker.io URL also. And as it now, when we look at the reports of, so basically we get a report of every pipeline, you get to see everything that happens, and this is where it's possibly flag any anomaly behavior. And you could see even so many things that you wouldn't even really care to look at. You see a report of all of those. um this is a core request to the local DNS stop, and that was passed. System resolve was passed, and this is the attempt to reach the webhook URL block, but that was blocked because our policy did not approve that we reach to this website. This is it also trying to reach a random page that just had github.com, and that was also blocked. And these are all TCP calls by Python, and that all those were passed. This is another attempt to which we get the process ID also. So this is another attempt to reach the webbook website and send that secret that we had, and that was also blocked. And this is so other, now here we could see that we're trying to get this artifacts file from this is the domain name that we get, but basically this is the come back the actual URL that is serving that content, and we can see that here. And all this was passed because we allowed it to pass. We allowed it to reach this URL. So this is the kind of reports you're going to get, and that's the end of the job, right? Now I understand that situations may arise where okay, you want to implement this into your CI/CD workflow, your CI/CD pipeline going forward. But then if you're an organization that have like multiple pipelines because you have multiple microservices, I can imagine it's going to be like a headache to have this to add this to every workflow. Though depending on your use case also, let's say there's some applications that you know, or you wanted to have, you wanted to be able to access some random website. So I have a sample here. Just switch my screen here. I have a sample here where you can have this entire control setup on your GitHub runner. That's if you have, if you're hosting a self-hosted GitHub runner. And basically, what's a self-hosted GitHub runner? The difference between this and the way we used it previously is previously GitHub gives you a random machine for you to run your CI/CD workflows, right? And normally you pay for, depending on how many hours your pipelines run for, you get to pay GitHub for that. While some organizations have their own machines that they have running these pipelines for them, right? And if you are doing that, you have a different level, a different level of granularity towards what your security policy is like. So other than having this is a YAML file that you could use to deploy your GitHub runner, your self-hosted runner, right? And you can now add this control as a sidecar to your GitHub runner manifest, and basically you have it install the control package and run it on your runner. That way, anybody that is working on any pipeline, as long as they are going to be using these runners, they will be, they already have control there. They already have, yeah, this control tool on their on the runner, and they'll be able to get reports, right? And also a cool feature about the control tool is also you to specify OPA policies. So now that also gives you a whole different level of control on things you want to restrict the runners to be able to do, and that way you know that these policies are applied for everyone and no one gets to bypass these policies, right? So
I
to
have
do that, go ahead.
I have a quick question. So you said that this is a open source and it can be run at every level of check. So how about in a place like in health technology based companies? How, because it's open source, how would they
Mm-hmm.
is there any way that, because health companies usually have to follow a HIPAA compliance or some kind of a compliance behind, right? So in that
Mm-hmm.
case, uh, I just wanted to know how, because it's a open source tool, so would there be any, I'm thinking in terms of whether it's even doable, in such an
Okay.
environment or a company where there is a
Yes,
compliance.
it's definitely doable because even though it's a health company, right, you're still trying to protect yourself from any malware, right? So it can check for that. And also, if there are policies that you want to specify, just because of like you're a health company and you really need these policies, um, you could also, like now we have an example where, oh, your runners can only run during business hours. So whatever example of that or whatever it is that, okay, this data, any information or any whenever any of our application pipelines are running, they can't send any data out to any particular region or stuff like that. You could specify them in policies like that. We have a policy here that I have a sample policy here that checks for
Oh,
password,
cool.
API key, tokens, the likes. I have environmental policies where, okay, if this is a dev environment, if it's a production um environment, then it must run. So it checks if checks if the environment is from development or production on stuff like this. So you can um make your own specifications here and just
Mhm.
apply it, and just apply those policies, just make them accessible and then just apply them here.
Okay.
Where is it? Wait. Okay.
Apply them
So
somewhere in the YAML file. That's what you mean.
yes, and the YAML
Okay,
file,
sounds good.
yes.
Yeah.
That way
Okay.
you can easily just, you don't have to interact with the control tool. You just, it's there doing its job. And if you have additional changes that you want to make, you can always come to your OAP policies and attach them there. Since it's looking at this folder, so whichever policy that is uploaded here is going to get picked up, and that's also going to be part of the requirements that it's checking as its policy requirement. Hmm. Okay. So this is a YAML template how you can run a self-hosted GitHub runner with control embedded in it. And I'll also share this repository that way if anyone wants to replicate it, because there is some level of requirements, I think machine requirements for you to be able to run this tool. I have a README file containing all of that and the type of machine type you're going to need for this. And basically, yeah, so yes, there's a config map that checks for the policies that you need. And that's it. So I also have a workflow file that uses coming. No, you, not this one. Okay. So now this is a workflow file that runs on. So if you look at the one previously, it's running on Ubuntu latest, which is the default runner provided by GitHub. Now, let's say this is the name of my own runner and it runs on this particular machine. So now that's a machine that I provided, right? And that machine already has these policies embedded in them. It already has control installed on the runner itself. That way you can see that I don't have to have the add the control step here. Um, and basically it does the same thing where it tries to send a secret to, basically the sample does the same thing that it tries to send the secret to this URL. And basically the only thing I may want to add is to attach a report. That way this report just for every pipeline that I have that is working on my runner, I can get to see a report of what's going on. What did you find? I mean, what malicious behavior did the tool find while this pipeline is running? And basically, that's it.
Is there any questions? Yama's here too. Thank you so much, Yama, for joining. It's midnight. It's about 3 a.m. for her. Is Rashida, do you have any slides that you can share? John is asking, is there also a link for previous series 1, 2, 3? Yes, we do have it. I posted the YouTube channel in here, Jonas. I will, yeah, I can share this again. So yes, all the series are recorded. You can take a look at it. Any questions for Rashida? Ask away. You can unmute yourself and ask if you are not able to type. Going once, twice. And Rashida, do you have all these things in your GitHub? Can you share this information?
Yes. Okay. Give me a moment. I just need to make it public. And but yeah,
Okay.
here is the.
You can send it to me later too. I can post it
Okay.
on LinkedIn. I will also attach it to the video that your video would be there. So I'll attach it to that.
Okay.
If you can give me the slides and the GitHub repo, so that I can
Okay.
attach it to the YouTube description. So I think if that's all you have for Rashida, I will let her. No, Rashida, if I would, before we let you go, let's take a picture. I know that it's late for you. I want to take a picture with you,
I,
and then I'll let go. You can go sleep. It's midnight, guys, for her. So I want her to go to sleep. So it's about 1 a.m. for her. So if people can, Rashida, you can stop sharing. If people can
okay.
turn on their cameras just for 1 second, I can take a picture, say good night to Rashida. Say, oh, this balloon keeps coming up. I don't like this at all. 1, 2, 3. Cheese. Okay. Rashida,
Oh no, I'm not.
okay.
Am I frozen?
I got it. No, I got it. So thank you so much, Rashida. If you want to drop off, please do. And if you guys have any questions, please, if you have any questions, you can connect with Rashida and ask. I want to let her go, and I want Emma to start. It's already 4 a.m. or 5 a.m. for her. So thank you so much, Rashida. But I will record, this recording will be there on the channel. Okay. I'm going to
All right.
stop
Thank you,
sharing
everyone.
now.